Good afternoon, everyone. A difficult task to keep engaged after lunch. But I'm Pranav Desai, representing Nuvoco Vistas Corporation Limited. I'll go mean that Nuvoco has a presence all India and the historical evaluation. We are with the cement plant over here by taking over Tata Cement actually, in 1999, and then the concrete by L&T takeover. So we always believe on, doing more and more innovative products, innovative production through the differentiated product. And that's what we are bringing today with the clear vision. Uh, we are the company who are mainly with the blended cement. So we have been contributing with fly ash, slag since many years. I mean, since the Tata days. But the recent are, there are certain cement products where we are mainly with the PPC cement or slag cement. And the one which is, the one which is, the one is the blue one, which is a water resistant cement, again in the PPC category, but it is a hydrophobic cement. And there are few innovations we brought in into the concrete using high SCM, the wet concrete in bag. It's a ready-to-use concrete in bag. I mean, we always think of that the water to be added and the concrete has to be used. Here it is like a ready-to-use. So today's topic will be discussing more on application of this allied slag. Because since morning, many speakers and our guest owners, and they have spoken about the slag, the quality and properties. So we actually did some application with that, and that's the presentation aim today that we take through it. And considering slag as an SCM, combustion product as an SCM, and as an aggregate. So these are the area of discussion for this allied slag. I'm not touching BF slag because a lot of things have been done and we are using BF slag. But the ACBF slag, LD slag, LF slag, the combustion product like fly ash has been that. But today I want to highlight more on a coarse and high alloy fly ash, which we have actually experimented and piloted at our ready mix plant, and of course bottom ash and pond ash. Using high SCM, there is a green concrete which has been developed and introduced by us in northern belt of India. Very well known phenomenon. The elemental analysis of SAG, it has been discussed by Dr. Chatterjee, other eminent speakers who have done earlier. But we see clearly BFS slag, LF slag, BOSF slag, it has a certain mineralogical composition, and this can be used, and we tried it. But the scenario is what? The statistics have been done, the varying numbers are there. Around blast furnace slag, we have 24 million ton per annum, 24 to 27 as Dr. Mohapatra has also mentioned. But the LD slag is around 12 million ton, which is there. So these are the statistics. The alarming situation is that by 2030, the BF slag will be available at 40 to 50 million ton per annum. And the LD slag again will be increasing by 10 to 15%, 15 to 20 million ton per annum, and of course the LF slag. So we tried to experiment this with these slags, and we said what could be the application areas using such products. So we know the BF slag is known to us, and it has been cement. We are producing this slag cement at Jamshedpur cement plant from the tune of 50 to 70%. So Professor Manu Sandham was saying, so we are actually using 65 to 67% of slag for one of our product. And of course, my attention today will be with the ACBF slag aggregate, what we have done. What I would like to mention over here, we have tried this at Hazira, Surat, considering monthly production of around 5,000 meter cube per one ready mix plant, because there is a main challenge that the slag availability near the concrete producing plant. If I put some statistic on that, replacing with ACBF slag up to 30%, which is allowed. Course said 25%, but we tried it with the 30% replacement. To the total conventional aggregate, the consumption can be 1275 tons per month. So the major challenge to be addressed by all producers, that where we can make this slag aggregate available. Did some analysis, chemical and physical. Uh, Considering this 4 category of slag, of course, thanks to Tata Steel, the slags are of Tata Steel only. And these are the properties what we could observe. However, the challenge with the SCBF slag, we have the glass content around 40%, which we found. And of course, the bond work index at around 70%, very hard to grind. So there is a challenge using SCBF slag as an SCM, maybe for the cement production, or maybe using SCM as an SCM to concrete production. But of course, there's a huge opportunity to be used, replacing fine aggregate as an aggregate. It has been, codal compliance have been checked with the same aggregate which we got it from TSL Jamshedpur. It indicates, clear indication is there, we can definitely use it as an aggregate. So that's what Mr. Anil Kumar is sitting, and we have been interacting since many months that how we can make it possible to use. This is where we can make it possible to use the ACPF slag for the concrete production as an aggregate. The few other applications, replacing conventional coarse aggregate. So what I am seeing, that has been tested, the laboratory analysis and of course the piloting. For the close aggregate, if you look at the properties, mechanical properties of concrete, like the workability as well as the compressive strength, the 28 days compressive strength has been found much better at the 30% replacement of aggregate. So that's the one clear conversion or application using ACBF slag aggregate in concrete. However, the code, I mean, we represent the BIS also. I was talking to Dr. Karandikar also, that there's a time to take it forward where we can increase the percentage doses of such aggregate. From 25, we can go up to 30. And there are evidented test results. Here are it is. So we've done this in Surat at ready-mix concrete plant near Hajira. You can see the mix design has been there. You can see the various compressive strength behavior right from first day to 28 days. For M25 grade concrete, if I consider FCK, characteristic strength of the concrete, even then I'm surpassing that, which is beyond 29 MPa. So that's what we got it while using the ACBF slag aggregate. Also the workability parameter, the slump, is around 110 mm at 150 minutes. Normally ready-mix supplier, we as a ready-mix supplier has to make concrete return up to 2.5 hours. So which is fulfilling those criteria by approaching that. So that was all about applicability of ACBF slag and prominently observed in a concrete as a coarse or fine aggregate replacement. LD slag, few attempts have been made. We made this experimental attempt by 4 approach, like using at 0.8 to 1% in a raw mix, feeding of LD slag at a kiln headlet. That is the process parameter, because we have been talking right now since morning how we can make this slag usable on a product term, but there are process challenges which are also to be addressed very well. Otherwise, as Mr. Prasad said, the circular, I mean the economy, if it is not economical, then there is no sustainability. So that's what we need to address. And of course, replacing BF slag by LD slag, few attempts have been made, and also we have made an attempt to replace the aggregate using LD slag. Commercially, it has been used as a performance enhancer up to 5% by various industries. There are some analyses. So first, as I said, raw mix component, you can see the challenge is the glass content. We were talking about that, what is the glass content we observe. That was the 10 to 15% we observed. And of course, the bond work index, 25 to 28%. So that's the main problem. However, the ferrous, you can see 15 to 25%. But adding this as a raw mix component, there won't be much challenge. You can always do it. It's about what mix you are designing. And our next speaker will also be highlighting on the same. But this can potentially benefit on the limestone consumption factor from 0.3 to 0.6, and rest you can replace laterite. So out of 1%, there is a possibility of using LD slag at the rate of 0.3 and 0.6 to 0.8%. Another way is using as an addition to kiln inlet. However, this is a patented product 20 years back. But this can be done, which can benefit us for the more clinker output. And of course, the C3S content is higher when we use the LD slag, which can enhance the early strength and setting. So these have been evidented at various laboratory level, and with us also, our experiment, that we were getting those properties enhanced. However, there are some limitation. Higher dosing replacing clinker or maybe a BF slag, there is a process limitations which we need to address. However, see, the LOI in the LD slag has been observed around 12%, but whereas the codal requirement as an entire slag stage, it should be less than 1.5%. We observed, we did this trial, it was 1.1%. Sorry, I have not put in this data because I was just getting this data. This was done two months back only. Material handling, as I said, separate setup is required to do this. So there are challenges on a process part. These are some data. Morning also, Dr. Mohapatra and Professor Manu has already informed that the LD slag has been taken up for the study with NCCM by Tata Steel. So we look forward to this, and we are looking forward to have a more discussion in BIS meetings also. But there are some analyses replacing BF slag in porcelain slag cement. So we have done this with the 1 or 2% BF slag replacement using LD slag at the various level. You can see the 1, 2, 3%. Of course, at 1%, 2%, the mechanical properties are attained. So that's the main benefit, even if you go up to that percent. The major challenge is that processing LD slag. So I go with the presenter, that how do we process? If there are good process techniques, and if you can blend this BF slag with LD slag to 10 to 15%, that is going to be a game changer for all industry. And the process is required. Though we are saying that there are some processes which have been adopted even at TSL level, but that has gone up to 10 to 15% glass content. We have done some crude method, I am not revealing out today, but we could improve it to 60, 67%. So further study is required how we can improve the glass content in the LD slag. Replacing as an aggregate, of course, we have certain limitation. The codal provision says we should not use it for the reinforced cement concrete as per IS 383. But this can be done. Believe me, what we have done, unsoundness test was getting past less than 1%, whereas the P2 of I is the major challenge, which we found. If we can do some process parameters adopted with some technologies, definitely it has a very high potential to be utilized in the concrete as an aggregate, replacing fine aggregate. LF slag, that's the new one we started. Somebody was asking about LF slag. So we did some analysis, and we attempted to replace clinker factor by around 0.8 to 1% using these LF slag. All said, it's good to use LF slag by replacing even up to 2%. We went with the 1%. It even shows the high content of residual material of C12A7 and the low verification of 10 to 20%. But with the limited dosage, is beneficial for using in slag cement. However, the LF slag is available on campaign basis. So if the Tata Steel will provide us on a consistent basis, definitely this can work well. This is the combined analysis of BF slag, LD slag, and LS slag. If you look at the combined analysis with the replacement ratio 98 to 1 to 1 between the BF, LD, and LF slag, the all chemical properties are matching, which is required for utilizing as a slag. So that is what we can do, and I can say that 1 to 2% of BF slag or clinker can be replaced using LF and LD slag. So these are the possibility how the LD slag, possibilities attempted, how the LD and LF slag can definitely replace the clinker and BF slag. That was all about the slag applicability and what we attempted and our experience which was said. About combustion product, these are the statistics we know. Somebody says in cement it has been used 24% or 25%. But the fact is that we have 230 million ton which has been generated. But more is that the 1.6 billion ton of fly ash is lying in a pond throughout the country. These are published data by Down to Earth fortnightly publications. And around 7.59 or 8% ash is unutilized out of this. So these are a statistic on Indian industry. What majorly affect utilization of this combustion product. Of course, the sulfur, free lime, which been talked, unburned carbon, and gradation and collection process. So this is function of all these factors which is affecting more utilization of such combustion product like fly ash. I would like to focus more on this unburned carbon element, which is there in coarse fly ash. So we are not using coarse fly ash or pond ash, but we made an attempt to use that. The certain limitations which codal compliances demands that your LOI should be less than 5 or equal to 5%. Uh, but, but what is the scenario? The scenario is that, the low fly ash is decreasing worldwide on account of controlling toxic gaseous emission, which is as per the 1990 Clean Air Act. So we attempted to use this coarse fly ash in our concrete plant, where we had some challenge of, we had some challenge of decoloration in concrete, poor air entrainment, no retention availability, say 2 to 3 hours, which is required commercially for any ready-mix concrete supply in India, and lower compressive strength. Particle size also put us a lot of challenge to use it. We developed jointly a carbon blocker, which is basically a surfactant element, which improves the workability, because workability was a major challenge where we have. So that basically improve on the air entraining behavior, and this is making workable. And we have consumed, as of now, around 3,000 tons of this pond ash and coarse fly ash at Gujarat and various other plants across the country, where we made this usable with a better dispensability. These are the results. Some of the results in the concrete means while using high LOI or coarse fly ash, where you can see the first column in the table, after parameter, it is without carbon blocker agent, and second one is with carbon blocker agent. The fly ash was sourced from Reliance at Hajira in Surat, where the LOI was found 10.53%. And we use that. You can compare the both. The pointer is not working, but you can see the properties. Little bit higher demand on the plasticizer because it has an unburned carbon. But what happens if you are not using such carbon blocker, then it will absorb more water. If it will absorb more water, it will demand more cement, and it will become uneconomical. So that is the main blocker for the user while using the pond ash or coarse ash or other unburned carbon ash which are lying in the dikes. But we did this, and this has resulted well. You can see the mechanical property, compressive strength, as well as the workability. The slump without carbon blocker was just 20, and retention after half an hour. Whereas with the carbon blocker, even after 2 hours, it was 125, which is pumpable slump for the concrete. Pond ash and bottom ash, we made an attempt to use it. Here is the change required. In the IS 383, we mentioned that bottom ash from thermal power plant. Why bottom ash from thermal power plant? We have a good quantity of bad ash from Tata Steel also. Those can be utilized for the same, maybe from other sources. This can be done. So we made an attempt to replace up to 25% this bottom ash. These are the data, of course, from the Tata Long products at Jamshedpur here. The major problem that we found was the water absorption, where the code allow IS 383 maximum to 5%, but we observed at 8.75% when the analysis was done at our laboratory as well as plant. So these are much coarser, and we need to make it workable. We did that, but the amazing and surprising result was observed that it was benefiting for the concrete behavior. You can see the rapid chloride penetration behavior at 25% bad ash replacement. It was around 3,000 column, whereas in the control mix it was 4,000. And with the strength behavior, you can see with the replacement of 25% of bad ash, the 28 days strength behavior, you can see it is much higher, 35 ampere, which has been tabulated over here also in the both trial mixes, trial mix 1 and trial mix 2. So that's how we made an attempt at ready-mix Jamshedpur plant for utilization of bad ash. So that's been a continuous effort by us to put it. The last topic which I want to discuss, that using high SCM, there is a commercialization, because the Conference theme says, what is the future trend? The future trend is that let's make something sustainable or something green by using such SCM. So we tried, and the presentation here includes that I want to focus more on higher proportion of SCM, whereas definitely it is giving us the benefit on embodied energy by making such mix using such SCM. So this is what the SCM, the 4 mixes have been tried. The first column which says, CO2 emission, what it could be at the conventional level, embodied CO2 emission kg per meter cube. If it has been used, concrete has been used with pure OPC mix, OPC cement mixes, and then of course with the SCM. So that's how we did, and we made an attempt by launching this product, by introducing this product, I would say, in northern belt of India, where the green product has been done to address the sustainability. Can I run that video, please? Just click on the black. Leave it. It's okay, leave it. Oh, there is one slide. Yeah. So what could be concluded if I do the SWOT analysis for valorization of such 2 industrial waste which we have discussed? I would not say now 2, but it can be more, because we made an attempt with using construction and demolition waste also for making concrete and all on that. But this is how we could summarize that we have a good strength. It can at least reduce the CO2 footprint for sure. It can give us the durable and better cement and concrete products. It is sustainable and economical, which shows us like using ACBF slag in a concrete, replacing aggregate, was actually giving a value benefit of cost reduction by 20-25 rupees a meter cube. And of course, that will result in the cement also. Whereas we do have a lot of challenges like lack of awareness. This has been discussed. There are myths, as Professor Manu Sandham was also saying, there are myths. We need to overcome to that myth. There are process constraints, because, when we were talking about LD slag, we are talking about LF slag. When we are talking about aggregate to the graded size requirement, there is a company like Tata, SAIL, and other steel manufacturers who are saying that you take it. But who is the converter? We are user. Who is the converter? So there are a lot of challenges on process part. We as an industry needs to pay an attention to create such converters where the more use of such SCM can be accelerated. Lots of opportunity. So it is not a waste now, it is a product, byproduct. So there are opportunity for more and more use of this SCMs. And the threat is standards and regulations. Of course, we need to amend something. We need to release something for more utilization of such SCM. Such data can definitely help us to, open up while mentioning or while specifying more fly ash in PPC cement, what Dr. Mahapatra says, 35 to 40%, or maybe more slag utilization, either as a part of raw mix or maybe a replacement of BF slag by such allied slag like ACBF and LD slag. With this, thank you very much. We would like to be a true reliable partner for your cement and concrete need. Thank you.
Thank you, sir. I request Dr. Atanu to please hand over the token of appreciation. Thank you, sir.